what is a Cascode circuit? Cascode circuit is this. It's just like a common source with degeneration. The reason is this. We do degeneration because our out equals to, I don't know if you still remember, R01 times 1 plus GM. Thank you. GMRS. I'm wrong. Plus RS, right? What we do is that instead of having a degeneration resistor, we have a degeneration transistor. Okay, so this is just like a current source. And we solved this problem before. This is RO2, right? And actually, we solved this before. So now the output impedance is RO1, 1 plus GM1, RO2 plus RO2. Right? So that is the so-called Cascode circuit. We put two transistors on top of each other. Right? So this is not spelling. If you do try to type your report, the word is going to say that you have spelling. Go back to Cascade, right? It's not. Cascode is like on top. Cascade is what? It's like this. Cascade is like you have the output. This output go to the next stage. Yeah, kind of like that, but not exactly. It can be confusing to say whether it's parallel or series, but the point is this. Actually, I don't know. Maybe you're right. Yeah, but just remember, don't mess up the cascade and cascode. Okay? In this particular case, it's the drain to the gate, and here is the drain to the source, right? You can even see this as an amplifier, because that's why I say maybe I'm wrong, right? Because this is one stage to another stage, common source to common source. I can also say that this is common source to common gate, right? Because this can be the input of the next stage. So let's just call Cascode as drain to the source, okay? Right, so this is what I showed you earlier, that this transistor just have RO2, so not input. But why do we want to do that? Why don't I just use something simple, right? Then it is very simple that because we want to increase the output impedance, right? Why do we want to have a higher output impedance? Again, why? Why? Why do I want to have a high output impedance? Yeah, can be have more like ideal current source, but what we're using is amplifier. We are not doing ideal current source, but very similar. Higher gain. Because I have a higher R out, right? So the goal is that you are the designer. You're going to invent something called Cascode circuit because you realize that I want to have a higher gain. Yeah, and definitely, if we make it as an ideal current source, then yes, higher output impedance, right? So actually, I should say higher gain for amplifier, and then more ideal for current source, right? Okay, so very good, you're right. So is this the last slide? Oh, okay, I don't have time for that. Then why don't I just use degeneration? Isn't that I already have something called degeneration? This is RS, this is V out, this is V in, right? I do have a very large gain output impedance, R out equals to, as you just told me, R01 times 1 plus GM, RS plus RS, right? The problem of degeneration is that its GM is also reduced. It becomes GM divided by 1 plus GM RS. So as a result, the gain is not change. Okay, so that is a problem of the degeneration, and that's why we want to use Cascode. Okay, I will continue next time. Then maybe, yeah, only 1 minute. Maybe I will talk about midterm next time then. Okay, let's stop here.